if you like knotting, you should absolutely learn about quandles. Quandles are idempotent racks. This means that they satisfy the self-distributivity of shelves, the invertibility of quasigroups, and the idempotence of an idempotent magma. Just the first two sets of axioms up there define racks, but when you add idempotence into the mix, you end up with a quandle, the perfect tool for knot theory. Let's see why. The reason why is that in knot theory there are three basic operations called the Reidemeister moves that govern how you're allowed to take one knot and transform it into an equivalent knot. So, for example, the first one, you can take a single string and make a loop in it around itself. You can take two strings and cross like a little bite of one underneath the other. Or you can take three strings, move the one in the middle while leaving the one at the top and the bottom unchanged. All of these operations probably feel super intuitive to you. This is why string diagrams are really powerful in other areas of mathematics, like category theory as well. Anyway, if you try to algebraicize those moves with a triangle roughly meaning crossing over, you'll find that the first one corresponds to idempotence. The second one, when you cross x over y and you can invert it, corresponds to invertibility, the quasigroup laws. And the third Reidemeister move, when you shuffle two strings underneath a third one, corresponds to self-distributivity. And altogether, that means that if you have any knot, the collection of all other knots which are equivalent to it form a quandle. Like there's a fundamental quandle for every knot up to knot equivalence. And if you can distinguish those quandles, you can also distinguish their corresponding knots.